Hi folks, Chuck Black here. We are doing 52 weeks of Python. We are in week number 20. And the topic this week is sets. Sets is an interesting and kind of fun data structure that is available in Python. We've talked about lists and dictionaries and tuples, and now we're going to talk a little bit about sets. I just noticed here as I'm reading through this, and I put this up here, a set is an unordered collection with no duplicate elements. Yeah, you can't have duplicates in sets. Basic uses include membership. That's where you're testing if something is in. And also there are mathematical operations, union, intersection, etc. And so those are all available in sets. What I'm going to do in this lesson is I'm going to introduce you and tell you how you can identify a set versus like a dictionary, which also happens to use these curly braces. I will talk about how items within a set need to be hashable so that the lookup for membership can go really fast. In the process of doing this, I tell you a little bit about the dir built-in function that helps you to know what operations are available on your particular variable or whatever it might be. And so yeah, that's what I'll be getting into. Hope you like it. Let's get started talking about sets. Okay, so let's talk about sets. And in order to do that, I'm going to drop into Python here, and we can examine some of the nuances and details of what a set is and how it behaves. Before we do that, as we get in here, I want to just review a little bit because we've been talking about different data structures. If I was to say L equals square bracket 1, 2, 3, 4, 4, close square bracket, and I was to ask you what type of data structure is that, you would, if you were answering me correctly, say that is a list. And I can just type in L and it gives me the data. I can type in type sub L or pass into this built-in function called type my variable called L, and it will tell me, oh, that it is actually a list. So internally it thinks of it as a class, this list type thing, but basically it's telling me that this is a list. And so if I was to do something different and I was to say D equals curly brackets A colon 1 B colon 2 close curly brackets, and I was to print it out, it would show that. And if I was to say type D, you already know what this is. You can tell by the curly brackets, you can tell that that is actually a dictionary. Now, we've recently talked about another type of data, and if I was to say T equals round bracket or parentheses 1, 2, 3, and I print it out, there you see it printed out with the round brackets. If I was to say type of T, you would know, okay, well, that is a tuple. So now that we've seen those three data types, let's do another data type. So if I was to say S equals curly brackets 1, 2, 3, close curly bracket, and if I was to print that out, it will print it out there. If I was to say type S, then it will tell me that that is a class set. And now you're saying to yourself, well, Chuck, that's pretty easy. I can tell that it's a list because lists have square brackets, dictionaries have curly brackets, tuples have round brackets, and sets have, well, hang on a minute, they also have curly brackets. So what's the difference if I was to print them out, if I was to do D and S right next to each other? And you could probably tell what the difference is. The difference is with D, I have this colon in here with values on either side. They're not actually values. This is the key. This is the value. On the left-hand side is the key, and then a colon, and then the right-hand side is a value. Dictionaries are extremely useful, as we've seen, for getting at data very quickly. You can reference via the key, and it gets you there, like if that key is the IP address or the MAC address or the name of something, etc. Dictionaries are extremely useful and used all over the place. Less used are these things that we call sets. Now, if you were to visually look at this, if I was a computer, would I be able to tell the difference? And the answer is yeah, if I'm a computer and I'm parsing this and I'm going left to right, as soon as I get to the comma, if I look in here and say, okay, well, if there's a colon and something on the left and something on the right, I know it's a dictionary. If I get here and there's a comma and I look on the left and there's just an item, which could be a string or a number or whatever, then I know that this is a set. So just a word to the wise here. Curly braces are used both for sets as well as for dictionaries. In most cases in the wild, when you're seeing a curly braces, curly brackets, then you will probably know that it is a dictionary, but there are going to be cases perhaps where you use sets. And I'm going to show you an example of kind of a fun networking example of using a set. But I will tell you I have not used sets myself in Python projects that I've worked on, but I've done in my life mainly C, C++, Java, and a little bit of Python projects, and so I haven't really done all that much, and others may have different experiences in terms of the amount of time they use sets. But let's look a little bit at what a set is. So what is a set useful for? Well, if you remember from your mathematics, you have a set which is a collection of items, and you can do things like find the intersection or find the union of those two. And you can do tests to see if a particular value is in a set. So if I was to say here again, I'm going to use this in order to make it easy. If I'm going to just say 1 in S. So here what I'm saying is I'm doing like an if statement, and I'm going to say if the number 1 is in S. And what this is going to do is it's going to evaluate it for me in Python, and it's going to tell me whether that's true or not. If you were confused by what I did, what you would normally see is something like this in Python. You would say if 1 is in S, and then you would say something like print S. And that actually shows that I indented it incorrectly. I hit a tab instead of spaces. So this gives you an example of what happens if you do a problem. If you have a problem within your actual Python code when you are using the Python interpreter like this, you will get something that tells you, yep, that's a problem. And in fact, you can see right here that I did not indent this correctly when I wanted to do it. If I was to do it again, let's try it again. I can use the up key. I'm going to say if 1 is in S, I'm going to do 1, 2, 3, 4, print S, and then hit return, and it printed S for me. So the shorthand way of doing that, of course, I can just say S here, and by default Python interprets that as a print statement. But the thing that we were looking at is 1 in S. That really is a relational operation or a comparative operation. It's going to compare 1 to see if it is actually in S, and it is. If I was to say 2 in S, the value will come back true. 3 in S, you're getting bored now. Why don't I try something different? 4 in S, false. Okay, so that's showing me that 4 in false, that evaluates to false. 4 in S, that evaluates to false. So that is one thing that sets are good for. You can find out if something is in that set. Now, from your mathematics background, if you have any, you may be familiar with the ideas of intersection and union. So let's do this. Let me say S1 equals S. So I'm going to have S1 equal that. I'm going to say S2 equals, and let's have some overlap here. So 2, 3, 4, 5, 6. So that is S2. So now S1 looks like this. S2 looks like that. So I'm going to say S1 dot union S2. And what this is going to do, it's going to put S1 and S2 together. And let's see what the result is. All right. So here, I want you to notice a couple of things. Number one, you say, oh, sure, that makes sense. It put them together, but it didn't actually do like an append, because if it did the append, then the result would be 1, 2, 3, 2, 3, 4, 5, 6. It didn't do that. For the ones that were duplicates, it didn't add them. And this is a unique characteristic of sets, is that you cannot have duplicates. If you try to add something, it will not throw an error, but it just won't add another value. So every item within a set is going to be unique. Okay, so that's if I were to do a union. What if I was to do an intersection? S1 dot intersect. By the way, I just learned today, you see that I just either typed in intersection really fast, or I hit the tab key to do autocomplete, and the latter is true. I hit the tab key, so I didn't realize I haven't used Python in here as much, so the tab key actually works in here. So S1 intersection S2, what do you think that would be? Well, looking at these two, you would say, okay, well, 2 and 3 are in both, and so that's what intersection means. And sure enough, it's showing this. And so you would be able to say things like, is 1 in S1? We know that that's true. Is 1 in S1 dot intersection of S2? And the answer is going to be false, because the intersection of S1 and S2 is S3. If I was to say, is 1 in S1 dot union of S2, then those of you that are on the ball will say the answer should be true, and sure enough, it is true. So that is in general what a set is all about. But before we leave here, I want to talk about a couple of things that are not directly related to sets, but are related to running your Python interpreter here in case you get in here. The first thing I want to say is, okay, well, how do I get out of here? I'm hitting Control C. It gives me a keyboard interrupt. That's not very good. That's not what I'm looking for. I can tell you if I do Control D, that will get me out of the Python interpreter. At least it will in when I'm running on Linux like Ubuntu, which is what I'm doing right now. Let me show you another way to get out in case you're in here. One way to get out, it's looking for Python code. So if I was to say exit, like the Python built-in function exit, and I need to put in open and close parentheses because I'm calling this function, then that has the same effect. It takes me out. So you can see that. So two ways to get out, at least in Linux, Control D and exit. I think when I've played around with this in Windows that they may not support Control D. I'm not sure, but a quick Google would tell you the answer to that. So let's go back, and I wanted to show you one more thing about running stuff in here. So I said S equals curly brackets 1, 2, 3. And I said list equals 1, 2, 3, let's say. And I said tuple equals, just for kicks, I'll do the same thing. There's no reason for me to do this except that I'm lazy. Let's do a dictionary equals. I'm just going to put one thing in here. And I'm going to say a key value of 1, and the value is actually 1. So I'm using integers for this. Now I have my 4 different data types here. Did you ever wonder, gee, I wonder what I could do to a set. I wonder what functions are available. Or maybe you've been like this. So I want to say, I want to add something to my list. So I say, oh, I want to add an item to the list. And so I come down here and I say L dot add 4. I want to add 4 to that list. And guess what? It's going to give me an attribute error. It says list object has no attribute add. And I'm going, what? Why is it telling me that? And let me tell you one thing that you can do. Of course, the intelligent thing for us to do would be to go over here and to Google Python list. And it'll probably come up with a number of things from Python. This is a Python tutorial. Let's see. Let me look at the documentation and see if this is what I'm looking at. here's a little bit on lists, and I can find out pretty quickly, oh wow, look at all of these things that I can do. This is really handy. I should have Googled this more often. And I can see right away, oh, I wanted to do an append. And if I was to come here and say L, whoops, see if I can type it correctly, append then if I'd hit tab complete, I would have known that I couldn't do that also. All right, so we've established that in my mind, probably going to the documentation is best because it actually describes it, but I'll tell you a quick story. So I spent the last probably, I don't know, 3 or 4 years of my life not writing software, but teaching people how to write software-defined networking software for the most part. And I also doubled as teaching people how to write Python. And so I was at some class in Atlanta in the United States, and I'll have to tell you, and I'm not saying this to brag, but people may have thought that I was good or bad as a teacher, but on technical knowledge, I always got excellent. So 1, 2, 3, 4, 5, 5 being excellent, I would get excellent. One person, the only time in my entire life where I've ever given a class and somebody gave me good as technical knowledge, dinged me because of the fact that I did not talk about the dir function in Python. And in fact, up to that point, I had never heard of nor used the dir function. Now, maybe using dir function is something that Python people do every day of the week. Myself, I've always looked at for what I needed. I found what I needed in the documentation or through looking at other stuff. But there's a function that you can call. Remember I said there's a function I could call called type of, like I could say type of L, and it will tell me that it's a list. I can say ID of L. We did this before when we were talking about mutable versus immutable. And there's this function I can call called dir. So I can say dir of L. And what it's going to do is it's going to give me a bunch of stuff that on first glance is going to look like a whole bunch of gobbledygook. What this is giving me is, oh, you can see here it's a list, but what is a list of? Well, if I just take off my computer imitating a computer glasses, and I think about this as a human being, then I look, okay, all these underscore ones are probably internal things. But when I get down here, oh, look, there's append. That's what I just did. Oh, clear. I can probably call clear. In fact, let's try that. I have no idea what will happen. L comma clear. This could backfire on me. Up. Okay, what's going to happen? L is now empty. All right. Well, so that worked like I thought it would work. I can do a copy. I can get a count. I can extend. That's when you put two lists together. I can specify an index. Let's see if this will do it in a friendly manner. Yeah. I can do an insert. So I can insert into a list at a particular areas. I can pop something off of the list. I can remove things. I can sort the list. So all of these things are the things that you're going to see over here. Do you see this that I've got? My command line window is going to go away when I do this for the most part. But you can see all of those things that we saw are pretty much right here. So what can I do to a set? So I can do dir parentheses s, and this will give me a whole bunch of underscore stuff. And then I'm going to look at what else I can do. Well, I've done an add before. Clear, that probably works the way that we thought. I can do copy. I can do the difference. Got to say, I haven't done that myself. You can do that yourself. Difference update, that probably takes the difference and updates one of them. I can probably discard an item. We did do intersection, and here you see intersection update right here. Is disjoint, is subset. I don't know. I've forgotten my math to know disjoint, but I know what a subset is. I know what a superset is. Pop is going to remove the most recently added thing. Remove is going to remove a particular item. You can do a symmetric difference. Up, and here's the one that we did. There is union. So this doesn't tell you anything about what they do. But and there's probably a way to do that. You can probably get the documentation for that function to print out the PyDoc documentation in a certain manner, and I haven't done that myself. You can look that up, but I did want you to be a little bit aware of this dir thing if you want to look and say, okay, well, why didn't my add work when I was doing a list? Well, because when I look here, I don't have the functionality to call add. I can call append or clear or copy or count, but there's not an add there. You see there's an internal add. That must be something that internally can be done to a list, but for my purposes as a user of a list class, then I can only do an append. All right, that's just a little diversion. Let's go back to talking about sets. So let's look at this code that I wrote to introduce and familiarize you guys with the idea of sets. So the actual application that I've chosen is the management of IP addresses. So I have two sets. One set is my available IP addresses, and one is the set of used IP addresses. And so what I'm going to do is I'm going to be playing around with those. Now I have a function here that I'm calling print IPs. I've fluctuated between this very simple version of printing them and a columnar, meaning in two different columns, versions of printing them. I'll show you what that looks like a little bit later, but I've got it set up so that it looks fairly reasonably well right here. And so what is my functionality going to do? My little application, it is going to first create a number of IP addresses. So it's actually going to add IP addresses to this set called available IPs, and it's going to do them in the range between 180 and 200. Now, this range functionality, as you know, it generates an enumeration of integer indices starting here and ending there. What we haven't talked about, and that you may or may not know, is that you can give it a skip count, or the number of, this is going to do every three numbers. So it's going to go 180, then 183, then 186, then 189, etc. until it reaches this, and then it's going to quit. So that's what I'm doing. I'm populating my available IPs with these IP addresses. So I'm just manufacturing these. And so what I'm going to do here after I print them out is I'm going to loop in this loop where I'm asking for an IP address to allocate. So I'm going to type in an IP address and I'm going to have it allocated. And if I don't pass in anything, in other words, if I just hit return, then it's going to exit the application. But the first thing it's going to do is it's going to check that entered IP address in the available IPs. I'm doing this set check to see if this is in the set of available IPs. And if it is, it's going to allocate the IP address by removing it from the available IPs and adding it to the used IPs. And the last thing that it does here is it's going to do an intersection. This is just a sanity checking to make sure that I never end up with an available IP address in the available IPs and in the used IPs. Obviously, that would be bad. So let's run this and see what happens. So I'm running it down here. Here's my list of available IPs. As I mentioned, 180, 183, 195, 186, 198, 189, 192. You say, well, wait a minute, why isn't that in the same order that we created them? Well, like with normal dictionaries, items in sets are not maintained in any particular order. And so you are not guaranteed things will be in the same order as you entered them. With lists are ordered. So you probably want to take a moment and write this down. I'll try to remember to put a little call out that says this. Lists are ordered. Tuples are ordered. That means that they are maintained in the same order that you put them in. It does not mean that they're sorted. It just means that they are ordered. Quite often we enter them in the order which happens to be sorted as well, so it's easy to confuse that, but they are ordered. However, sets and dictionaries, neither of them in their natural version are ordered, so they don't maintain their order. So I added them: 180, 183, 186, what's next? 189, see if I can do math, 192, 195, and 198. That's the order that I entered them in, but you can see very vividly they are not ordered here, so they're going to be in whatever order they were in. Now I have nothing in my used IPs, and for some reason what Python does is it prints out this statement, which is basically telling me that it is a set, but it has nothing in it. That's an empty set. It could also have printed curly open brackets, curly close brackets with nothing in between it. That's perfectly legitimate as well also. But I think for the way that they like to do things in Python these days is they would prefer to reference the actual name of the data type, which is set, and do these parentheses when it's empty. So I'm going to allocate an IP address. Let me choose one at random in the middle here. I'm going to do Control C. I'm going to do Control B to put it in. So when this is done, we should see 195 in the used IPs, and it should have vacated the available IPs. Let's see if this works. So there's 195 as a used IP address, and you can see, looking at this, that there's one fewer IP address in the list of available IPs. If I was to pick off the next one, I can do that, and we're going to end up getting rid of another one. You can see now we're even less. As we go through here, I've got even fewer. I can pick off another one in whatever order that I want and type that in. And at this point, you can see it's going down by one. Eventually, I will have used all of them up, and there won't be any available IP addresses. In fact, did I catch that situation? If IP address is in the list of available IPs. So basically, you need to type in something in the available IPs, and if it's not, then I say IP address not found in list of available IPs. So this is just my silly little program, but it prints these things out. Let's play around with this and try to generate something that will be an error. So let's kill this, and let me get rid of this removal. So let's say I wrote code that forgot to do this. By the way, in PyCharm, the way that I did that hashtag to make this into a comment is I did control / or forward stroke, if that's what you call it where you're from, and basically that turns this into a comment. And so I've done that. Now everything's going to be the same as before, except I'm going to forget to remove it. And so what should happen is when I come in here and I do available IPs.intersection with used IPs, this should always be 0, but if it's greater than 0, then I know, oops, I've got a problem. So let me run this again, and we'll take a look at what happens. Now I'm going to choose one of these at random. Notice the actual order is even different than it was last time. So here we go. I'm going to try to allocate this, and I allocated the IP address. I printed them out, and you can see that I'm saying I used this, but guess what? If I look up here, I can see, I forgot to delete it or remove it from available IPs. And sure enough, I printed out this error. How did I know that? I knew it via this comparison. I did an intersection, and I tried to see if it was greater than 0, because as I think you'll agree, there should never be an IP address in the list of available IPs and in the list of used IPs. So let me undo this. And let's stop. Let's actually, let me do this. Okay, so let me run this again. And the first thing that I'm going to do is I'm going to type in something that doesn't exist, just so we can exercise that code. If you're writing tests, you'll want to be doing stuff like this. IP address not found in available IPs. Okay, so let's take this one here and just make sure that it works correctly, that I deleted things appropriately. So that looks like it worked correctly, so we're good to go there. So let me just show you the last thing here. Let me show you the other way of printing this out. All right, so I am going to uncomment. I'm going to comment these two lines. Again, control / is your friend. Boom. I just forward slashed all of those, and I'm going to / all of these, which will make them into living and breathing statements in Python. And let's have a look at this. For this, I'm going to move this over to the top, the right. Let's see, the right bottom, right top, whatever. It's a little bit easier to see over here. All right, and I'm going to get rid of this so that we have some room. Here I am, enter IP address to allocate. I'm going to do Control-C and Control-V. Let's see if this works. Hopefully I did this correctly. So I allocated 10.0.195. If I was to grab another one, and Control-C, Control-V. So you can get the general idea of what's going on here. I did this originally. This is the original way I did to print it out. I kind of used a lazy man's way of printing it out. There's a lot of code in here. You'll find that sometimes printing things out can be, or even just doing anything can be more of a pain than you wanted it to be. I took the poor man's, stupid man's way of doing this. I turned my available IPs into a list. You can do that. So I've turned a set into a list. In fact, maybe it's useful to explain this to you. So for printing them out, I turned them both into lists. So now I have two lists. Now, if I wanted to enumerate, in fact, this is probably good as I look at this. Let's talk about this. This isn't just a useless exercise. So what I'm going to say is if the length of available IPs is greater than the length of used IPs, then what I'm going to go and need to do is I'm going to need to go put blanks for all of these used IPs so that when I iterate through it, it'll print it out correctly. Now you may be saying there's got to be a better way to do that, and I can pretty much assure you that there is, but this is how I chose to do it because it was quick and dirty, as we say in the software development vernacular. Quick and dirty, some people call it cheap and cheerful. Depends on whether you think that it's cheerful to be doing it. So basically, I'm going to do this. I'm going to add spaces so that I can just iterate through these one at a time and print them out because, you know, I'm printing things one line at a time. And so what I'm going to do is I'm going to be adding these. So at the end, both of these lists, remember, I changed them into lists. I'm not modifying the original thing. I am modifying the list that we have, and I've put blanks on so they're ready to be printed. How do I iterate through two lists at the same time? This is important, iterating through two lists at exactly the same time. Let me show. This is the magic statement that allows you to do it. Basically, it's this thing right here. It's this built-in function. Let me move my cursor so you can read it. It's called zip. I have not looked up why that is called zipped. I think of zip as WinZip and compressed stuff, etc. But basically, if you want to iterate through two things at the same time, this is what you do. I'm going to iterate through my available IPs list. That's the thing right here, which is from the available IP set. And I'm going to iterate through used IPs. And the item that is from available IP, I'm calling available IP. The used IP is used IP. And then I'm doing my fancy F string with formatting where I take my available IP and I shove it to the right. I format it inside these 16 characters. Used IP, I left justify it. So you can kind of see here that available is going to be right justified and used is going to be left justified in those 16 characters. And so you can see as I'm going through here that, yeah, I don't really need to show you this, but it's going to be getting more and more on the used side of these things. That's what I did. So what did I show you? Why is this useful to show you this? I didn't even realize it before I uncommented it, but I'm glad that I did now. We changed a set into a list. Yes, you can do that. This is kind of a handy thing that can be done with Python. Then what I did was I padded one side or the other. That would be, over here. I padded it with blanks. The reason that I padded it with blanks is because I wanted to use this for statement where I iterated through these and I went to the end. If this list was less than that list, what would it do? It would basically stop when it got to the shortest one. And so, like in this situation, it would have only printed the first line and it wouldn't have done any of the others. So what I could have done, I'm realizing this now, instead of doing this, is I could have a second for statement that just iterated through the one that was longer and printed them out appropriately. And that would probably be pretty easy to do. It might be less lines. I would have to figure out which one do I need to print. I need to print either that or this. Yeah, maybe I'll do that just for grins when I'm done here. But that is sets, and that is printing them out like this. So hopefully you've gotten a general idea of how we might use sets in the real world. If I'm a DNS service, then I might do something like this. I can pretty much guarantee you that they don't, because they're not going to be written in Python, is my assumption. But if you are going to implement one in Python, this might be a reasonable way to do it, at least if you're doing it in the context of wanting to use sets. So hopefully that has helped you have a better idea of what actually they might be used for in a real world, in our case in the networking world. So we've learned about sets, the intersection, and then we learned a little bit about some other stuff too, like converting a set to a list and using this zip functionality. Okay, there's one more really important thing that I haven't gone into yet with respect to sets that is extremely important, and I'm going to go over that right now. Let's look at this statement right here. If IP address in available IP. So basically that's taking this IP address and it's checking to see if it is in the list of available IPs. So it's basically looking up here to see if it exists there. Now, and that is what this statement right here is doing. All very self-explanatory, easy to understand, etc. And looking here, if you were pretending to be the computer, then you'd say, oh yeah, well, just scanning through that, there it is. What if I had chosen a different one, like this one, 183? Well, then I would go through here and here and here and here and here, and eventually I'd get to 183 and I'd say, yep, sure, that's in there. And so what I want to tell you is that is exactly not how Python does it. And in order to think why Python doesn't do it that way, imagine that instead of this many devices, of which there's 1, 2, 3, 4, 5, 6, 7, imagine there was 20 of these. Well, that would take a little bit longer. Imagine there's 100. Even as a human, that would take longer. What if there was 1,000? What if there was 10,000? What if there was 100,000? How long would it take to find a single IP address in a collection of IP addresses if I was going through them one at a time and trying to figure out if that was it? And the answer is that just wouldn't make any sense whatsoever. Okay, that is not how Python would end up doing it. And so let me tell you, and we're going to come back to a word that we've talked about before, and this word is important. I introduced it when we talked about tuples. I mentioned it in our discussion of tuples when I talked about keys in a dictionary. It's a word that I'm trying to figure out a way to get you to guess what it is without giving it away. It starts with H, it ends with ubble, and it has an ash in the middle, okay? It is the word hashable. And so what I'm telling you is that every item in a set must be hashable. That means Python must be able to take it and be assured that it's not going to change, so it has to be immutable. And that goes for all of potentially the sub-items within that particular item. Here I just have a string, but what if I tried to use a list as an item or a dictionary as an item in a set? And the answer is that would not work. The reason is this: how can Python execute this statement here if IP address is in available IPs? The way that it does it is Python maintains a hash table of all of the items in the set. So basically, Python has a hash table with all of these items in it. And what that means is it has converted each of these strings into a key. All right? So each one of these is like a key. And so when I say if IP address is in available IPs, all that Python has to do is it has to take the IP address, in my situation 10.1.0.1.186, hash it, which means turn it into a key, and you can look that up as well. I'll probably talk about it later on in our discussion. You don't need to know the details now, but it will hash it, and then it will look it up in the list, not the list, but the collection of all of these keys. In the hash table, as you recall from our lists versus dictionaries, when we looked things up via the key, it was basically instantaneous. So this allows Python to instantaneously do this comparison if IP address is in available IPs. Everything in the set must be, what's that H word again? I'll give you a second to think of it. It must be hashable. And that is how Python is able to execute this statement like immediately. And you may think, well, that's not really that big a deal. But remember, if you had 30,000 of these IP addresses and you wanted to do IP address in available IPs, and if it was a list, it would have to go through it one at a time and figure out. And if it was the 30,000th IP address, you can imagine how much slower that would be than it would be to just be able to look this up. It's effectively the same thing as what we talked about in our lists versus dictionaries comparison. So hashable, very important characteristic of sets. All of the items in the set must be hashable. That allows Python to do this in comparison and have it work really quickly. Okay, so let's quickly review what we talked about. Our discussion today was on sets. We talked about how you define them with curly braces, very similar to the way that you do dictionaries, but dictionaries have key value pairs and sets, of course, just have items in them. We talked a little bit about what you can do with sets. You can do things like take the union, you can do intersection. One of the main ones that we talked about a little bit more is you can do in, so you can find out if the number 1 is in the set S1 in that example. We looked at examples where we created sets for available and used IPs, and then we ended up creating a bunch of IP addresses in the available IPs and then allowing you to come down and specify an IP address to utilize, and that would get added to the used IPs and removed from the available IPs. And we used this test right here in, and then we showed how, just for sanity's sake, we could check to see if the intersection of the two available IPs and used IPs, the intersection should always be 0, and if it's greater than 0, then that's a problem. So hopefully you have a better understanding of sets. Oh yes, we also talked about how sets, the items in sets, needed to be hashable. Why is that? So that we can do this test quite quickly. If we had to iterate through every single item in a set, it would take forever. So items in a set need to be hashable. Hopefully that's useful. If you use sets, this will hopefully be helpful to you in understanding what sets are and why we use them and how we use them. Thanks.